All right, so this is just going to be a short video bringing together all the concepts I talked about in my previous two videos where I kind of unpacked why algebra works. And we're just going to apply this to solving a couple of problems here. So we are taking the exact same ideas, and if you need some more context, feel free to check out those videos. But we established that because we have all of these numbers multiplying by like terms. So what's important here to note is that these x's, whatever they are, they're the same number. And these y's as well, they are the same number. And these coefficients, these numbers in front of them, so this 3, 2, -1, and 4, they are multiplying by that number. And we established that by adding like terms, by adding these products with the same factor, we can just add these coefficients together. So what we're going to do right now, we are just going to add and find the like terms. So just for ease, I'm going to just add another step here. I'm going to rearrange my expression here and group the like terms together. So I'm going to say, this is like saying 3x plus 4x. I've put the x's together here, kind of right next to each other, and 2y minus y. Now that we can kind of observe these next to each other, we can just perform our additions or subtractions with the coefficients. So my 3x plus 4x, that just becomes 7x. And plus 2y minus y, anytime we have like a y or an x or anything just on its own, we can think of that as just 1 being multiplied by y. Because 1 times any number just gives us that number. So it holds that 1 times y just gives us y. But that actually allows us to compute this bit, in which we are going to just minus 1y from 2y. And we are just going to get left with y here. Let's try a couple more just to get you used to these kind of initial preliminary operations with adding and subtracting algebraic terms. So let's take 4a plus 8b minus, let's go 2a plus 7b. Now you can see, once again, we can group our like terms together. These like terms are just our pronumerals, our letters here. So because of what we talked about in the last two videos, we can add these because they have the same product. This a is like a common factor in the expressions 4a and say -2a, as well as 8b and 7b. So now we can just simplify this. We can bring these together, and I'm going to just do this again, just so you can see these terms really grouped together. I could even take it one step further and just like put brackets around them. So you can just see that we compute these one by one because we are dealing here with the a terms, we are dealing here with the b terms. But once again, we just end up subtracting 2 from 4, subtracting these coefficients, giving us 2a. And in this case, we have two positive ones, 8 and 7. So we are going to add these to give us 15b. Let's do just one more example for good measure. And this should give you a little bit more comfort in terms of actually working with algebraic terms. And this subject extends far beyond what we're doing here, but it's important to get the foundation. So feel free to check out the other video if you really want a slow conceptual investigation into why this works. Sorry, contextual investigation, I should say. But here we're just computing this. So I'm doing this video with the assumption that you've watched the previous ones, or you've got a good grasp on why it is that we can add these terms. All right, so let's keep working through. Let's do minus 2f plus 5f minus 3d plus d. Okay, so I added an extra term here. Before we were dealing with, kind of just pairs, but it doesn't change the way we work through this. Now, I'm going to once again group all my things. So we have 6 lots of d. From that, we're subtracting 3 lots of d, and then we're adding 1 lot of d. Once again, I'm just going to put brackets around these. You don't have to, but this just helps me identify, okay, I know which groups I'm working with. I've isolated my d's here, my like terms, and I'm also going to isolate these here as well. 2f plus 5f. Okay. Just keeping these separate. Now we work through them one by one. We have 6 lots of d minus 3 lots of d. That's going to give us 3 lots of d plus d. And minus 2f plus 5f, that is going to give us positive 3f. Because adding 2 lots of f from this 5 will bring us to 0. And then we just have 3f left over. So adding 3f to 0 gives us 3f here. All right, now we have one more step. And I've gone through this deliberately slowly just to show you that you can take your time with these. Obviously, by the end, you're going to be just flying through these, but I'm deliberately slowing this down so you can get each individual step. Now, I'm left with 3 lots of d plus d. Now, I mentioned in the previous example, this is like saying 1 lot of d. So 3 plus 1 gives us 4d plus 3f. And that's our example. Done. Now, we can extend this to include a bunch of different terms. Like we could even, let's do one more example. We can have as many different terms as we want. We can do, for example, 3a minus 2b plus 3b plus, let's go 5c minus a plus 4c minus 3c. It doesn't really matter how many we add. Here I've got a third set of like terms. I've got a, b, and c. And we can work through this the same way. I'm going to group these again. I'm going to be left with 3a minus a. They're my first set of like terms. 3a minus a. And then I have here, and the order doesn't matter either. Sorry, I'm being a bit fussy with the colors. But for example, to make this easier, I can just treat this as 3b minus 2b. So the order in which I arrange these doesn't matter. I personally like to have my positive first, to think of me subtracting the negative from my positive, because, 4 plus 2 is the same as 2 plus 4. The order in which we add does not matter. So that's why I can just change this around in a way that makes sense to me. And this may make sense to you as well. And to that, I'm going to add 5c plus 4c minus 3c. So 5c plus 4c minus 3c. And I can deal with these all one by one. 3a minus a, 3 minus 1. We have this imaginary 1 here. Not imaginary, it's always going to be there because any number multiplied by 1 gives us that number. So we are left with 2a here. 3b minus 2b gives us positive b. And 5c plus 4c equals 9c minus 3c. And taking one more step, I am going to subtract 3 lots of c from 9 lots of c. And working with these coefficients, these numbers before, I will get left with 6c. Now, hopefully this video has given you just a good idea of how we can work through examples like this. And hopefully when you come across certain examples, even like this one, where we have a lot of terms, don't get too overwhelmed, because we can just isolate all of these like terms. We can group them together. We can rearrange this in a way that makes sense to us. And we just work through these one by one. The laws of algebra let us add and subtract these like terms because these terms work like real numbers. This is just our regular arithmetic applied to unknown terms. And we'll find out as you progress through algebra, this can be quite a useful tool. So that's all for these initial algebra examples, and I'll see you guys next time.